Right now
Progress.
we are going to the next speaker. Sorry, Ot Otgontsetseg Sukhbaatar, Ph.D. Right. Okay. I would like to introduce first before you arrange your PPT. Yeah. Otgontsetseg Sukhbaatar was born in Ulaanbaatar, Mongolia. Uh, she received her BS degree from the National University of Mongolia and MS degree in electrical engineering and computer science from Seoul National University, South Korea, and her PhD degree in computer science and electrical engineering from Kumamoto University, Japan. She is currently the head of the Center for Faculty Department at Faculty Development and Digital Learning, National University of Mongolia. Her field study includes learning analytics, machine learning in e-learning, and educational data analysis. Right now, she's going to present a paper about maybe a result about uh, sorry, application machine learning algorithms to enhance the learning process. To Otgontsetseg Sukhbaatar, PhD. Time is yours, about 20 minutes. Thank
Okay.
you.
Thank you, Marisa, for introduction. And thank you for the organizing committee to invite me to give a speech on this conference. And okay. My slide is shown, right?
Yes.
Okay,
Yes.
thank you. Okay, the title of my presentation is Application of Machine Learning Algorithms to Enhance the Learning Process. And actually, instead of presenting one specific paper, I decided to make a presentation about how the machine learning algorithms can enhance the learning process. So because I see that audiences from very different research fields, so the more common understanding will be more interesting to the audience. So okay. As we all know, with the introduction of the personal computer, the learning content started to shift to be digital, and with the spread of the use of internet and the learning management systems rise, and the education became online. And in 2012, there were many massive open online courses providers emerged, and the education is became widely available for everyone and for free, right? And with the introduction of the massive open online courses and introduction of the learning management system, they start to collect a lot of data in the learning management systems and from the massive open online courses. Since then, the researchers start to extensively study how those data can be used to improve the education itself and maybe the learning process. And so with these changes, the educational data, people understood that educational data should be used to improve the learning activities and the outcome. And actually, there is endless possibilities and opportunities. So in this talk, I will talk about how the machine learning algorithms are used to enhance the learning process. So as we all know, the machine learning is like a subset of the artificial intelligence. And actually that one helps to teach machines, the computers, to collect the data and learn from the all previous data and to make the very intelligent decisions in the future. So how the researchers are working to like using the machine learning to improve the education. Semesters data is used for the testing and 5 semesters data used for training, something like that. And this shows the results of the study. And actually we started to predict the performance, like whether students will be failing or successing from the beginning of the semester. And only after one quiz, it means that at the second week of the semester, the students' performances and all the students' activities are collected and used for determining whether the students will fail. And the accuracy of the model showed overall of over 84% of overall accuracy. But in terms of the sensitivity, number of the correctly predicted failing students shows in this graph. Only after 1 week of the semester, the 25% of the failing students are correctly predicted. And in the mid of the semester, for example, the eighth week of the semester, 53% of the failing students are correctly predicted. And actually, we were how to say, more eager to test whether it's feasible to predict the failing students at early stage of semester. So we only used the first weeks of the semester, because in many studies they're how to say predicting the using whole semester data, and they are seeing whether it's possible to predict the students failure in the whole semester data. But in terms of the learning process, at the end of the semester, for example, and the 10th week of the semester, if we predict the students are failing or not, it doesn't make sense, because student itself can't work harder and make it pass the course. But even the instructor can do anything. So because of that, we are more concentrated on whether we can predict the failing students the early stage of the semester. So the 25% and 53% is actually not that good prediction outcome, but in terms of the early stage of the semester, it's quite promising. And actually these kind of results can be, how to say, improved using many other data. For example, this one was a DSP course, digital signal processing course. So maybe we can use the previous prerequisite courses final grade or some other demographic GPA or other data to improve the prediction accuracy. And actually this paper is published in International Journal of Emerging Technologies and Learning. And if you want to have a more deep insight of the paper, you can check out the paper. And as the summary, the machine learning in education is actually extensively studied for last couple of years. And actually this one can be used for many learning process and learning outcomes. And for example, like a build of models to provide a personalized feedback on the student's progress, and content analytics, for example, organizing and optimizing assessment, textbook sessions and lecture videos, and scheduling algorithms for optimal and adapted teaching policy so that the students can learn more efficiently, and also prediction of learning outcomes, for example, risk of dropout or risk of failing students. And even the field of study can be predicted using the students' entrance exam and other behavioral characteristics. So this is the wrap up of my talk, and thank you for your attention.
Thank you very much, Otgontsetseg Sukhbaatar. How can I call you? Your name?
You can call me just Otgon for short.
Oh,
Otgon.
okay.
Yes.
Thank
Okay.
you. Okay, thank you, Otgon, for your very nice presentation. I see here in my private chat there are one question about the how can we gain the retention time by using your behavior prediction approach. You mentioned about behavior prediction approach, right? On your slide, and you also mentioned the retention time of the learning. Yeah.
Those kind of research usually is based on the, also it's possible from the log data, also it's possible from the classroom observation using the cameras. For example, from the log data from LMSs, students are usually like, when students are logging in quite frequently, and in every login, if the students are accessing the course materials or watching lecture videos, and at least like trying some of the quizzes, and then over the time, students' activities, like how to say, going down. At the beginning of the semester, probably students are more active, and all of the students are very actively participated in the course activities on LMS. But over the time, it's like it's becoming less and less, and then after maybe several weeks, some portion of the students won't log into the LMS, and based on the data from the previous students who drop out the course, then we train the model based on those data, and then model itself will learn what kind of activities on LMS will proceed to the dropouts, and based on that, if the model detects some kind of similar activities, then model can detect those students will drop out, and this one will retain the course and continue with the studying. Such kind of studies is can be done on the LMS data. And also there is a possibility using the camera, for example, in the classroom activities. If as I shown in the previous slides, there is some studies conducted by several universities using the cameras on the classroom, and those studies see whether the students are attentively attending the classroom activities. From that, it's also possible to whether the students are understanding the course contents and whether they will continue with the course. So these kind of things can be, how to say, these kind of things can be used for the dropouts. Also for the retention, if the students are, how to say, if the students are watching the courses, how to say, some of the videos are watched only for 10 minutes. For example, the video is 30 minutes, and also the 10 minutes videos watched most of the students. And then it also the, how to say, indication of the whether the student will watch the course until the end or something like that. So these kind of things also will be very, I have to say, not easily, but it can be detected from the log data and also classroom activities using the cameras.
Okay.
Does it answer your question?
Yeah. So,
okay.
Thank you, Otton. I see that there are two participants who raised their hand. The first one may be M.Si want to ask a question, please.
Okay, thank you, Ms. Marisa. Hi, Ms. Sukhbaatar. In your presentation, you show us that you choose 8 features to make a prediction about the failing for the students. So I'm curious about how do you select the features? What do you think? If you increase the features or you make it smaller, how does it does it have any effect to the accuracy and the sensitivity of your model? And then the second is okay. Likewise, when you select the train in the data, the size of the data set, does it any effect to the accuracy for your model?
Okay. Thank you. Thank you for your question. Actually, it's a quite good question. And actually, the features on the slides are selected based on the many, how to say, trial executions. Because actually, this one is blended learning course, right? If it was the full online course, there can be many other, how to say, LMS activities, but the course itself was classroom lecture, traditional classroom lecture plus LMS activities for quiz and midterm and also some assignments. So this is the blended learning course. Because of that, for example, we can't collect, for example, lecture video related features. For example, there can be many other features based on the lecture videos, duration of the video and how many percentage of the videos has been seen or something like that. But it was a blended course and the LMS activity was very limited. Usually this kind of research is used full online course. So we wanted to try whether this kind of study can be done on the blended learning course because LMS activity is very limited. So because of that, and there was about 17 features extracted from the LMS data, and we only used most important ones, which affects the performance highly. And I think this one answers the first question. And for the training, we used, as I said, we used the 6-fold cross-validation, right? Usually, like training and test data separation is done using, random separation, right? But we wanted to use, because we will use these data based on the semester, group of students, and we will collect the data and we will use it on the previous, in the future, these are next semester's data, right? So because of that, we wanted to just see whether these kind of training and test set separation will work. And actually this one is showed not that different accuracy compared to the random separation. So we still wanted to try to do the training and data separation based on the group of semester data. And
Okay.
what was the other question?
Okay, the other participant who raised their his hand, Mr. Eki Latumakulita. Maybe Mr. Eki want to ask a question. Thank you.
Hello.
Hi, Miss Otgon. It's a long time.
Long time no see.
Maybe just the question is out of the topic. I just make sure if we arrange the same even in next year, if you come to Manado, if we will arrange, to make sure.
Okay. For the next series of this conference, right?
The same conference. So I will. I want to make sure that I can see you face to face.
Okay. Okay. Thank you for the invitation. Okay. If like this COVID situation is loosen up, and if the borders are opened, and if the next year you invite me for this conference again, then I will surely participate.
Okay. Thank you. See you.
Thank you.
Thank you, Mr. Eki. I think you put delivery question about her presentation. Okay.
Okay, thank you so much.
Thank you. Thank you, Otgon, for your interesting presentation. Give us a very, very good insight for us about digital learning. Maybe as a beginner, I want to present your certificate as a presenter today. Maybe our chair, maybe Mrs. Susan, would you help me to present the? Okay, where is where is where is the certificate? Maybe committee.
Okay,
Okay.
Mrs. Susan, you can share now.
Okay. Okay. This is your certificate. Thank you very much for your presentation. As Mr. Eki said, maybe we will see next year. I will see you next
I
year.
hope you see you in the
Okay.
Manado next year. Okay, thank you.
Thank you very much, Otgon. Okay.